Good morning, students. How are you all? Hope you're fine with the grace of the Almighty God. So, students, as you know that yesterday I have explained the chapter, and this chapter is very short. And our topic of the chapter is motion of the earth, and chapter 3 from the geography part. As you know, the chapters is about the rotations and the revolutions. So let us watch an animation and understand this chapter far better. So here on the screen, you can see the chapter's explanation. Okay, so let us get started.
Motions of the Earth. Our planet Earth has two types of movements, namely rotation and revolution. The movement of the Earth around the Sun on a fixed path or orbit is called revolution. The spinning of the Earth on its axis is called rotation. Rotation. Rotation is the movement of the Earth that causes day and night. The Earth spins on its axis from west to east. The axis of the Earth is an imaginary line which makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. Rotation divides the Earth into a lighted half and a dark half. The circle that separates the dark part from the lighted part is known as the circle of illumination. So, we have day as the lighted part and night as the dark part on the Earth. They follow each other in all parts of the Earth. Seasonal changes occur due to the inclination of the Earth's axis. If the axis on the Earth was vertical, then there would have been an equal duration of day and night. There would have been no change in seasons also. If the Earth did not rotate, what would have happened? The half of the Earth facing the Sun would have been extremely hot and the other half freezing cold. The portion of Earth facing the Sun would have always experienced day, and the other half would have always remained in darkness. Life would not have been possible in such extreme conditions. The rotation of the Earth results in heat and light and darkness as well. This change from day to night causes temperature variations on the Earth. There is an increase in temperature during the day and decrease in temperature at night. Trivia. Earth's rotation period relative to the fixed stars is called its stellar day by the International Earth Rotation and Reference System Service (IERS). On a prograde planet like the Earth, the stellar day is shorter than the solar day. Revolution. The second motion of the Earth around the Sun on an elliptical orbit is called revolution. Elliptical orbit means that part of Earth around the Sun is of oval shape and not round or circular. The Earth completes one revolution in a period of 365 days and 6 hours. We consider a year consisting of 365 days only and ignore 6 hours for the sake of convenience. These remaining 6 hours every year are added to make one day. One day is equal to 24 hours over a span of 4 years. This surplus day is added in the month of February. Thus, every fourth year, the month of February has 29 days instead of 28 days. Such a year in which the month of February comprises 29 days is known as a leap year. So, a leap year comes once every 4 years. The year 2012 was a leap year followed by 2016. Find out when will the next leap year be? Cycle of seasons. The inclination of the Earth's axis and the revolution on its orbit are together responsible for the change of seasons throughout the year. Summer solstice. Look at figure number 4.2. You will find that on 21st June, the northern hemisphere is tilted towards the Sun. The rays of the Sun fall directly on the Tropic of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the sun are slanting. The North Pole is inclined towards the sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. There is summer season in the Northern Hemisphere and winter season in the Southern Hemisphere. In the Northern Hemisphere, it is the longest day and the shortest night, while in the Southern Hemisphere, it is the shortest day and longest night. Trivia. To visualize the motion of the Earth, picture a top spinning on a table. As the top slows down, it starts to wobble. While Earth is in no danger of stopping its daily rotation, it nonetheless wobbles on its axis. Imagine a line running through the poles and out into space. Continuing up or down, this line traces an imaginary circle among the polar stars every 26,000 years. Practically, precession is difficult to notice as the stars only shift about 1 degree every 70 years. This motion was first noticed by the great classical astronomer Hipparchus, who, upon using some old star charts, noticed that every single star whose position he measured was a few degrees away from where it should have been. From the Arctic Circle to North Pole, the whole area experiences sunshine for 24 hours. This is known as the phenomenon of the midnight sun. The countries of Norway and Sweden experience this phenomenon. The whole area from the Antarctic Circle to the South Pole experiences darkness for 24 hours. This position of the Earth is called summer solstice. Autumn equinox. From summer solstice position, the Earth gradually moves on, and on 23rd September, it reaches the position of autumn equinox. The length of day starts decreasing in Northern Hemisphere. The opposite of it takes place in Southern Hemisphere. The North Pole and South Pole remain equidistant from the Sun on 23rd September. The sun rays fall vertically on the equator, and the days and nights become equal all over the world. This period in the Northern Hemisphere is called autumn season, and in the Southern Hemisphere is called spring season. Winter solstice. From autumn equinox, the Earth gradually moves and it reaches the position of winter solstice on 22nd of December. The South Pole remains inclined towards the Sun on this day, and the sun rays fall vertically on the Tropic of Capricorn. The day becomes shortest and the night as longest in Northern Hemisphere and vice versa in Southern Hemisphere. The Northern Hemisphere experiences winter season while the Southern Hemisphere experiences summer season. Spring equinox. On 21st March, the Sun remains equidistant from the North Pole and the South Pole. Hence, the sun rays fall vertically on the equator. The days and nights become equal all over the world. This period in the Northern Hemisphere is called spring equinox, and in the Southern Hemisphere, autumn equinox. If the Earth did not revolve around the Sun on its inclined axis, there would be no seasons. Because of the inclination of Earth's axis, each pole takes turn to tilt towards the Sun. It explains why each hemisphere has different seasons in a period of 1 year. It happens because Earth is in constant motion around the Sun on an inclined axis. Thus, there are changes in the duration of days and nights, and there are changes in seasons because of the rotation and revolution of the Earth respectively.
So students, I hope that you understood the explanation of the chapter. So till then that take care. Thank you. Bye bye students. I hope that you will come on Monday, live classes. I'll be giving out the question answers on the Monday. So bye bye everyone.